Here is all my work and answers for this one. We got this bottle of milk problem, and it gives us a derivative. It also mentions that it is less than 40. So I don't need to, when I'm doing my slope field, I don't need to worry about this portion of the graph. So part A, you're just meant to. It also tells us the beginning at time t equals 0. The milk is 5 degrees Celsius. So I got that initial starting point right there, and I'm just kind of following those slope fields right there and approaching that horizontal y-asymptote. That's all you need to do for part A is just kind of trace that. Part B, we're using a tangent line to approximate something. So remember, you need two things to write the equation of the tangent line is you need a point and the slope. So the point is the t equals 0 to 5 degrees Celsius. So I know I'm going to use 0.5 as my point. So I can go y minus that y value equals some slope and then x minus the x value right away. To get the slope at this point, you need to plug stuff into the derivative. So when t equals 0, the milk is 5 degrees Celsius right there. So you got to plug in the 5, not the 0. Okay, so that's the milk temperature right there. So then that's going to be 35 over 4 for the slope. Do the point slope form. The x is your time. The y is your milk temperature. And so I just switched the m's and t's there. And so I just got my equation of the tangent line. And then we're supposed to approximate m of 2. So I plugged in 2 for that, the t, and then I figured out that that was 45 over 2 degrees Celsius right there. All we had to do for part C, find the equation and then plug it in, get that estimated value. Now part C is a couple parts there. So you're first going to find the second derivative. So there's your first derivative. You need to take the derivative of that. So that constant's going to carry down. When you take the derivative of negative m, that's going to be a negative 1. But then since you took the derivative of m's, you got to tag on the dm dt. Just like if you take the derivative of y's on an implicit differentiation problem, you got to tag on that dy dx. So the 1/4 that carries down, the derivative of this is a negative 1, but since you're taking derivative of m's with respect to time, you got to tag on the dm dt. And then it says in terms of m, which means it doesn't want dm dt in my second derivative. It just wants m in my second derivative there. So that's negative 1/4 dm dt. So now we need to take what the dm dt is equal to and plug that in place for the dm dt. So that's what I did right there. And there's an expression for the second derivative. So that's the first part of it, the second derivative in terms of m. And then it says use that second derivative. So you know when you figure out whether the second derivative is positive or negative, you know that tells you about the concavity of the graph right there. And that's what you should be thinking about. And to determine whether this approximation that we found in part B is an under or over estimate right here. So they told us that m is less than 40 for all values of t. So if m is less than 40 and you do a 40 minus a number less than itself, that 40 minus a number less than itself is always going to be positive. So this binomial is always going to be positive, and then you're always times it by that negative 1 over 16. So you always have a negative times a positive, which means your second derivative is always going to be negative. If your second derivative is always negative, that means your original function, your original curve is going to be concave down, and you're using the tangent line to approximate stuff. So it helps me to draw this little picture right here. So I drew just a general curve that's concave down, which means at that point, the tangent line is above the actual curve. Since it's going concave down, spilling the water, your tangent line is above it. And so your tangent line approximation, so your point is on the actual tangent line, but your curve, since it's concave down, is actually down here. So your approximation is an overestimate right there. And then letter D is going to be a strength of ours. Separation of variables. You want to find the particular solution to the differential equation. And so those directions, if you forgot them, those are going to be in your blue packet right there, where you're going to integrate both sides. Remember the plus c, and then use the point that they give you to figure out what that c value is. So here is all my work for letter D. See if I can zoom in on this a little bit more. All right, so separations of variables. So I first move the dt to the other side, and you need to lock those differentials into place. And you need to get the m's with the dm. So I divided both sides, do legal algebra, got the m's with the dm. And any type of numbers or t's, I just leave that with the dt. You want all the extra stuff over there because you're going to have to move it back over anyways, because you're supposed to get m equals something. And then so now we integrate both sides. So when I integrate this, my u is at bottom, the du is a -1. So you get a balance of negative, and you do have 1 over a single letter. So that's going to be negative ln, but make sure you balance that negative. That's an easy integral there. Always put the plus c on the side the x's are on or the t's are on, and then use that point that they give you to figure out what that initial condition is. So we'll take the 5, plug it in for the m, take the 0, plug it in there for the t, and we get our c value, and then we can plug that back in right there. And anytime I have ln's on both sides of the equation, if I want to get that nice answer that the AP grader has with their rubric, I always move my ln's to the same side. So I just add that over, and then I use my pre-cal stuff to make that a single log. So that's why I turn it into a fraction. Use your pre-cal properties there, and then do your main definition of log. You're going to go e to that equals that, and I multiply both sides by that. Also divided both sides by that at the same time. Solve this for the m right there, and then that's our final answer. You got to come up with what m is equal to. So if you have any little questions about any parts of that, please let me know. But you got practice, we could handle doing stuff like that and do really good on that. Blade of grass.